Hi everybody, in this video we're going to set up our first set of scenes with a player and some basic physics and just experiment with how we can move the player within our game world. All right, here we are. So chapter 1, episode 1, we're going to be just focusing on creating the player scene. If you're unfamiliar with the concept of a scene, just like what we've created here with the playground, this is a scene. We can make custom scenes that are used for certain things in the game. So the player scene is going to be the scene that encapsulates the player, all of his functionality, and all of his code. And then that way that scene is controlled and, kind of managed in the game. If you're coming from other game engines, like maybe Unity, this is kind of like a prefab, but this is what we're going to be doing. And then we're going to be using this playground scene as our initial test level. So we'll plop some things in here as well and use that just to kind of play around. So I'm going to go ahead and actually start. Let's go ahead and start with the playground and let's clear out this sprite for the icon. We don't really need that. Instead, and I'm going to go ahead and rename my root node from node 2D to playground. That'll help me remember where I am. I'm going to hit Control A and we're going to add a new node here. We could just add a node 2D, but to start, I want to add a sprite. Oop, what did I type? There we go. A sprite 2D. Now a sprite node in 2D is obviously used for displaying a sprite. I hope that makes some sense. A sprite is just a texture, right? And so you can see here we have a texture property for this sprite 2D. And because we're just starting with the basics here, we're not going to get too much into textures just yet because, one thing that is really easy to get carried away with, especially for someone like me who is an artist first and I want to just make all the cool sprites. If we focus on that before we build the game, then sometimes we do things backwards and we make poor decisions. So what we're going to do is we're just going to choose, there is like a placeholder texture. We could use that. We'll use that for our player. I'm going to pick a gradient texture 2D. This is going to allow us to define, that's what the placeholder texture looks like, by the way, that pink thing. But a gradient is just a gradient, right? So we pick some gradient stop colors. And actually, I'm just going to click on that. So, once we've added that texture, we've got parameters here. I'm going to click on the gradient. These are stops. I'm going to click on this white stop and double click it. And I'm going to change the color to black. Okay. So this way I've just got a black box. Nothing too fancy. But this is just going to be used to block out some examples in our world. And then we could also look at the size. I know that my game is going to be using 32 by 32 pixel grid in our tile set. And so what I'm going to do is underneath the texture here, I'm just going to expand that again and find the width and height of this gradient texture we're creating and set it to 32. Okay, so that's one block in my world. That's going to give us a good reference for size while we're just blocking things out. Before we do anything else with this sprite, right now it's just here at the origin of the game world, right? You can see where it crosses the X and the Y axis, and that's the position 0, 0. I want to add more to this sprite. So a sprite is useful for displaying graphics, but in order for there to be any interaction with the player, we also need a collision body. And there are multiple types of collision bodies in Godot. And the one that we want for like our world and for things like this ground that aren't moving, they're not animated, they just need to be there for like the player to land on, we're going to add a static body. So I'm going to press Control A again, or alternatively, you could right click on the sprite because we're going to add it as a child. And we can say add child node. You see that's the shortcut there. And the child node that we want, I'm going to type in the search here, is a static body 2D. You can see that this is under the 2D nodes and it's a type of collision object. It's a physics body and it's static body. And what's nice is if you're going through here, let's say you're just kind of browsing. I'm going to go ahead and clear that search. Let's say you're looking under the 2D nodes and you're like, okay, yeah, there's collision nodes. And you can see there's an area 2D. And these give really useful descriptions down here. So this is a region of 2D space defined by collision shape, right? And it detects when other collision object 2Ds enter or exit, and it keeps track of which ones haven't exited yet. Overlapping shapes. But I just want to point that out. For those of you who are new, you can really get a lot of information out of these. So static body 2D is right here. You can see that there's an animatable body 2D. We won't use that this early in the project, and we'll use that for like making a moving platform. But for a regular ground, a static body, a static 2D physics body, it can't be moved by external forces or contacts, but can be moved manually by other means, such as code. It's funny that it says that. It can be moved, but it's not ideal for moving and interacting with other things. So we're just going to create that static body. You can see that it's got this warning. These warnings are configuration warnings. It's like, hey, something's not set up for this to work. You can see that this node has no shape, so it can't collide or interact with other objects. And so what we need to do is actually add another child node, and this is a collision shape 2D. So I just type COLL in the search, and you can see that collision shape 2D pulled up. And now when I create this, we have yet another configuration warning. And this may seem kind of annoying, but trust me, this is a great system. I love Godot systems. This collision shape just requires a shape definition. And when we click on that, you can see that we have options. We could make a circle, rectangle, or capsule, and some other shape options. But what we really need for this is obviously a rectangle. And here we can see the rectangle, right, displayed here. When you have something like this, if you're on this move or select mode, then you can drag these edges. If you click one of these corners and say hold Alt, then it's going to drag proportionately, which is really nice. So you could drag and just resize this. You could also come into this rectangle and set the size manually. You can see it's 32 by 32 pixels, which makes sense. It matches the size of this sprite that we created. But now with all of this set up, we have the basics that we need to be able to create this simple world that we're going to test in. Now that we've got this shape, what we can do is, what's kind of fun, I guess, is if we resize this sprite, because these nodes are children of the sprite, they're going to inherit the same scaling parameters. So just select this and, oops, if you click, you might just click the top object, which is what I did. If you select a sprite and resize it, you can see that the static body is resizing with the sprite. And that's going to allow us to really quickly make a floor. So what I'm going to do is I'm just going to drag this to be as wide as this blue box. You can see I zoomed out. If you recall from our first video where we were setting up our project, this is kind of what like the camera view. And so I'm going to select this, and then you can take this move tool, or you can leave it on here and just click and drag. But again, if you do that, it might not select properly. So I like to learn these shortcuts. This the shortcut for this is W. So you press the W key and now you can just move whatever you have selected. And I'm just going to move this down to the bottom of my world like that. I'm going to select Q again, or press Q so that I'm back to this select mode. And then you can resize this if needed. Okay, so this effectively is going to be the floor of my world. And if I press F5 and run my project, because we've already got the scene set up, you can see there it is. There's the ground. That's that rectangle that we just made. Okay, that's going to be the floor that our player will fall onto as we get started here. Now, I know I'm covering some of these concepts relatively quickly. So, you know, if at any point you don't quite understand, go ahead and drop a comment in the comments section, and maybe I can add a clarifying video or slow down in the next one. But the next thing that we're going to do is we're going to create that player scene that I mentioned at the beginning. Okay, and so what we'll do is, before we just create a player scene, I'm going to make a new folder. Because if you look at our file system and our project resources, you can see that there's not a lot in here. You won't have this add-ons folder. You'll probably only see, you know, your playground, readme, and this file. And these two files were files that I added as I created my GitHub repo and created my custom project icon. So you might not have either of those, and you might still have the Godot icon, but those are all fine. Just as an explainer, this add-ons folder contains the add-ons that help me display myself here in the bottom right corner, as well as things like my little shortcut pop-outs. Okay, so ignore that add-ons folder. That's just for my own recording purposes. So I'm going to just click on this resource, the root folder, and I'm going to right click and say create new folder. And the first folder that we're going to create for our project is for our player. And the way I like to structure my project is kind of by entity and function. And so I'm just going to make a folder for the player because he's a really important entity in the game. And there's going to be a lot in the way of assets, scripts, and scenes to make the player work. So it's nice for him to have his own dedicated folder. Now let's just go ahead and create a new folders underneath this, because there are things we'll be adding to our player in the future. We're not going to add them now, but this will give you a vision of the folder structure that I like to create. So the first thing that we're definitely going to have are going to be sprites, and we will get to these in chapter 1, just not in this video. Okay, so we're going to have a sprites folder, and then we can create another folder for scripts. So all of our gdscript files are going to go in that folder. I'm going to make a folder for sound effects, And in fact, maybe instead of calling it sound effects, I call it audio. That makes it a little bit more distinct, because otherwise they all start with S. And then I'm going to create yet another folder, which is kind of synonymous with scripts in a way, but these are going to be our states, our player states, because I do want to keep these separate. So I'm going to make a states folder. But there we go. We've got these folders, and they're going to stay empty, but this is how we're going to organize our different assets and resources for our player. And now that we've got this set up, let's right-click on player and say, create new scene. And it's going to create a scene within this folder. And you're going to have some options here. Obviously, we're in a 2D game, so you could pick that this is a 2D scene. If for some reason you needed to pick a different type, you could come here and select it. And in fact, we do in this case, because our player is going to be a special type of scene. And I'm just going to type it. It's character body 2D. Okay. So you can see that was underneath collision objects. And you can see this character body is a specialized class for physics bodies that are meant to be user controlled. This is important, and this is something I want to focus on just a little bit. It says they are not affected by physics at all, but they affect other physics bodies in their path. I'm going to go ahead and pick that. And I think that's important to note. I think, generally when beginners start making games, and I can speak from experience, you kind of think, okay, well, my player should be affected by physics, so I need it to be some sort of physics, rigid body, and yada, yada, yada. And that generally doesn't work out very well unless you're trying to build a very specific type of game where maybe I'm thinking of like a pinball machine or something like that, where you want the physics to be simulated very accurately. Then maybe you want to pick something like that. But this character body 2D provides exactly what we want. It allows us to interact with physics, but it isn't necessarily going to be controlled by physics. And we don't really want that because, again, we don't want our player to roll down a hill or anything like that, right? He should just be able to run up and down it. And if we use a real physics body, then we're going to be fighting with the physics system the whole time. Okay, so let's give this scene, was that a good enough explanation? That was a lot. I'm going to call this scene player, and you can see it's going to have an extension of TSCN, and the root name will be player, which is nice. So let's go ahead and say okay, and it'll open that scene. Voila, and you can see it opened it in a new tab, and here's our scene. It's a character body 2D, and you've got a motion mode and some directionality and things like that. And you can see that it saved it here in our player folder. And this is perfect. That's exactly what we want it to do. I'm gonna go ahead and save that. And then let's configure just a few things in this player scene so that it makes it easier to work with. Now, one thing that we definitely need right now is we need to add a sprite 2D for our player. And we're not going to be adding the actual sprite to this player until towards the end of this chapter, because I don't want to be distracted by it. But let's go ahead and go under texture and just say placeholder texture. Okay, it made a little thing over here, this little pink box. And if you remember, one version of myself was kind of disappointed by that. But this placeholder texture, we can give it a size. And the rough size of my player is going to be 18 pixels wide by about 48 pixels tall. He's got cool spiky hair. That's going to be taller than 48 pixels, but that's roughly the size I want. Okay, so you can see how that works. Now, another thing that's going on here is you can see that this is centered around the origin, and it's extended evenly out from that center point. But I don't really want it to be that way. I want the center point to be the bottom where his feet are. That just makes it easier for me to imagine things and to do math and things like that when I'm kind of writing the code. So I'm going to drag that up so it lines up just right there with the bottom. You could also go over here to the transform in the inspector and give it a negative 24 px offset, right? Because if it's 48 pixels tall, but that's measuring from the center, it's 24 up and down. Okay, and counterintuitively, negative 24 means up by 24 pixels, positive 24 would be down. You would kind of think that 24 would be up, or negative 24 would be down, and vice versa, but this is how it works, okay? Now you can also see that our player has this configuration warning. We encounter this again. This node has no shape, so it can't collide or interact with other objects. Consider adding a collision shape 2D or collision polygon 2D. So let's do that. Control A, COLL, type that in there, get our collision shape 2D and create it. And just like we did with that other sprite, we need to define the shape. So I'm just going to go down here and add a new rectangle shape. Okay. Now this rectangle shape I'm going to make it, in fact, I'm going to make it a tiny bit smaller, 16 pixels wide. Let's make it 46 pixels tall. You could make it exactly the same, you know, do what you want to do. And then I'm going to drag this up as well, just like that, okay? So this is the collision shape of my player, and this is the sprite, right? And they're separate. And one thing I like to do, you can change the color of these shapes. I think blue is fine, a good debug color for the player. You can also drag this alpha so that it becomes more or less opaque. And I don't want to see it too much. I'm going to drag this down a little bit. You'll still be able to see that full color outline in blue. But yeah, oh, looks like I've got a little warning here. Another resource loaded from path player, player.tscwn. I'm not sure what that is. Hopefully it doesn't affect us. And if you see an error like that, you know, sometimes things like this might happen as you're adding nodes or making adjustments. Now that we've got this scene, let's go ahead and go here to our playground, and you can see how this will begin to work. We're going to take our player scene, and you can just drag it out here into this playground, into the scene world, or you could even drag it up here and drop it. And if we drop it up here, it's going to just put it at the origin right here in the middle. If we drag and drop it out into the world, then it's going to leave it wherever we drop it, okay? And so I think this is a good way to do it. Let's just drag it out here. And now if I run the project, nice, we can see that we've got a player and we've got the ground. And probably the least dynamic player you could have because it does absolutely nothing. Let's go ahead and go back to our player scene now at this point. And let's make it so that this guy does something, okay? And what we want to do at this point is actually add our first script to the project. And there's a couple ways we can do this. If we just come up to the player and right click, then there's an option to attach a script. And you can see that it's going to try and save it here in the player folder. It's called player.gdscript, which I think is fine. It's telling us that it inherits character body 2D, and you can pick a language, but our project is only configured to work with gdscript, and we're not really going to be changing that in this series. But I'm going to go ahead and change this folder. So I'm going to click down here, and I'm going to navigate to my scripts folder, and then click open. Oops, did I not double click that? Scripts folder, and then click open. There we go. So now it's going to be player/scripts/player_gd, and then I'll say create. And you can see now that this player has a little script icon on it, and it's opened this script here in my editor. And you can see this is one of my add-on scripts, Juice My Editor. I'm going to close that for now. Okay, so this script, it says it extends character body 2D. If you are new to programming in gdscript, what this means is that we're taking and inheriting the functionality that's built into the character body 2D, and we're going to build off of that in this script, right? So whatever we tell the script it can do, it can also do what this one can do. And one piece of homework that you can do is come in here. It's really nice. You can obviously hover over this and get a description, but if you hold Control or Command on a Mac and click on any of these green types, it'll actually open the documentation for it. So you can see this is the character body 2D class. It's got a description of what this class is, which we kind of already read. It's got links to online tutorials, which could be useful. It's got a list of all the properties, which are like the variables that are part of that script. And it has all of the methods. These are all of the functions that we can call and utilize as we're working with the script. And this will give you a really good sense of what it's capable of and maybe what it isn't capable of, right? Like just looking at this, we can see that there's some really handy things in here, like get floor normal. That might not make sense, but you can tell that it has something to do with the floor. You can see if there's a wall normal, you can get, is it on the ceiling? Is it on the floor? Is it on a wall? And then there's this move and slide. So there's all sorts of stuff built in here. And you could click on one of those, like, what is move and slide? And it'll tell you, moves the body based on velocity. If the body collides with another, it will slide along the other body, by default only on floor, rather than stop immediately. If the other body is a character body 2D or rigid body 2D, it will also be affected by the motion of the other body. You can use this to make moving and rotating platforms or to make nodes push other nodes. Okay, and then there's obviously a little bit more. And we're not going to get too deep into it, but become familiar with the documentation because Godot has amazing documentation, and it's really going to help you level up your understanding of programming if you refer to this often. So going back to the player, there's one thing I do want to do with this. On line 1, I'm going to add, before the extends, I'm going to type class player. And what this does is it tells the game, or it tells the engine that I want this to have a unique class name called player, okay? And that's not going to make a huge difference for some scripts, and then it might be really important for others. But this class player is the equivalent of having a class, you know, like this character body 2D in its script, it would start with class, character body 2D, okay? And then it extends something. In fact, if we look, what does it extend? If we come up here, you can see that character body 2D inherits physics body 2D, which inherits collision body, which inherits node 2D. And so this is kind of fun. You could go through an exercise and go up the tree, and you could see all of the properties and methods that belong to that, all the way up to a node 2D. A node 2D's got a global position, a position, rotation, so on and so forth. So you can see how these things are really complex. And this means our player also has all of the same stuff. And while we're getting into the nitty gritty of these classes, it's worth pointing out that many of these properties, I should say these properties are exposed in the inspector. You see global position, rotation. If we select our player here, which is a character body 2D, you can see we've got a transform which has those position, rotation, and so on. Now, closing these documentations, let's just focus on this player script for a little bit. And this should read class name. I'm sorry, not class. Okay, class name, very important. If you didn't catch this, catch it. Should be class name, player. Now, we're going to begin by leveraging a built-in function that's on all of our node 2Ds. And I'm going to start by typing func for function underscore physics. And as I start typing this, you can see there's an autocomplete hint because it recognizes that I might be looking for this. And I want the physics process. Okay. And I'm going to type underscore delta here and then go to the next line and maybe 2 down and type pass. What pass says is do nothing, but it's kind of required. You notice before that it's going to have an error because it's like, hey, we're expecting an indented block of code after this, right? So you can do pass to get rid of that warning. And I like to leave the pass a lot of times just because that pink pass helps my eye see that, oh, that's the end of this function. What the physics process is it's a process that runs on a fixed tick or interval in the engine, and it's used for all of the physics calculations. The name would tell us that much. And this is important because it's not frame rate dependent. There is another process that's called just process. And in fact, I'll go ahead and add that right now, okay? And this process runs every frame and every tick in the game, which is frame rate dependent. And I'm going to put an underscore on these deltas. What this means is that if your game is running at 60 frames per second, then you're going to get 60 of these calls per second. But if your game is running at 240 frames per second, you're going to get 240. And so you have to be careful how you use process and physics process. The physics process is going to be locked at a frame rate set in your project settings, which by default is 60 frames per second. And it's locked so that you can accurately produce the physics types of calculations that you need to. And if the game speeds up or slows down, we're not going to get any, odd behaviors. Whereas if you try to do velocity on the process, an important factor in something like movement speed is distance and time, right? And if the time is variable, then that means your speed is going to change. And so that's why we wouldn't do anything that we're doing in physics. We probably wouldn't want to do it up here in process. Or if we did, we would have to be very careful. With that said, both of these have this delta parameter or argument. And what the delta is it's the time since the last tick or frame. And in fact, if we click on one of these, you'll see the delta is a float. Physics process is called once per physics tick. It allows the node to synchronize their logic with the physics ticks. Delta is the logical time between physics ticks in seconds and is equal to this, you can see this engine, physics ticks per second, okay? So again, we're getting pretty into the weeds, but hopefully some of this is making sense. Maybe watch it again if it didn't, but just know that this is how much time has passed since the last time this function ran, okay? This is kind of the base loop of our games, the code that's going to consistently run. Now what we're going to do is we're going to add here this move and slide call. And if you remember, we saw that while we were looking at our character body 2D, and we can call that function. And what this will do is it will move it based on a velocity. And so if we save this, I'm going to go ahead and just look. Because we have our playground defined as our root scene, I can just press F5 and it's going to run it. And that code has not yet done anything with our player, right? But we can see that we have no errors, so that's good. I'm going to click on the script and come back in here. Now let's try assigning a velocity to this player, and then we'll see what happens. So I'm going to just say velocity, and I'm going to modify just the X, because the velocity has an X, a horizontal, and a Y, or a vertical component. And so I'm going to just set this equal to, let's say it's 10.0, and let's run again. Nice. Super nice. It's moving. If we were to just set this to a higher number, like 100, then we'll see it'll move a lot quicker. Okay. Very good. And we could set it to 0, which is what it was at by default. And if we run, then obviously nothing's happening. Now, at the same time, we can do the same thing with our Y velocity. So let's adjust the Y velocity, and let's set it to 10. No, let's set it to 100. It's going to move down, but you'll notice it's now being impeded by the ground. So you can see how our player could work, right? It's being forced down by the code with the velocity, but it collided with a static body, so it stopped moving. So let's set this to 0. I'm going to go ahead and just comment this out here, this velocity X. And for the velocity Y, we're going to do this. We're going to say, instead of setting it equal to 0, we're going to say it's equal to the current velocity plus. So we're going to increase it. Okay, we're going to increase the velocity over time. This is how we'll simulate physics on our player. And in this case, let's assume that we have like a gravity of 98 units, right? Because gravity is what, 90? It's like 98 feet per second, or I don't know what. How do you say that? And I guess I'm screwing this up all over the place, because gravity is actually not 98 but 9.8, and that's like meters per second. Okay. So let's just assume that instead of meters, we've got units, which our unit is pretty small. So we'll have to adjust this, but the velocity is going to increase by this amount. And because this is over amount of time, what we need to do is we need to multiply the gravity by our delta. Okay. Because like I was saying, if gravity is, let's say this was meters, if it was 9.8 meters per second, right? But we've only elapsed like a fraction of a second, then we can multiply this by that, and we can see how much that gravity has increased over the last period of time, okay? And because of the order of operations, this will calculate first, and then it will add to this. So now, if we run our project, we'll see that the player will fall more and more rapidly over time. But that was really slow, because this 9.8 is like meters, but we're in pixel units, and I don't even know. I think 980 is going to be more appropriate. And just to test this a little bit better, let's go over to our playground, and I'm going to take our player, and I'm just going to move him up pretty high like that. Yoink. Okay, that felt pretty good. Okay, so the gravity is 980 units per second, or at least that's the acceleration of our gravity. And now we have this player that's falling to the ground. And it still, of course, stops when it hits the ground, right? Which is nice, because we've got that physics all set up. Or that static body, I should say. Okay, let's jump back into the player again. And actually, that was a new shortcut, wasn't it? So you can see this is a scene. This player is a scene. If you click on the little scene icon, it'll open it in the editor. Boop, it'll pop it open. It was just there, but it's a nice, easy way to navigate through. Let's go ahead and open the script again. So now that we're properly manipulating this Y velocity, let's go back to the X velocity. And what we're going to want to do with the X velocity is we're going to want to set it to something only if we're pressing a button. So we could say that the velocity equals 0. And then here's where we're going to start tying into some of our input systems. And if you recall, in our project setup, we had set up our input map here. So you can see in the input map, we've got left and right. So we're going to utilize the left and right. And I've got mine set up to work with the joypad left, keyboard left, and the joystick axis left on my gamepad. And same with the right, right? So what we can do is we can type in here, if input with a capital I, which accesses this global or static class of input in the Godot engine, dot, and then there's is action pressed. Okay, you see that? And then we're going to pick left. And this is just asking, this if is asking, is that action being pressed? Is that input binding being held down? And if it is, then we're going to set our velocity dot x equals -100. Else if, actually not just else, but if. And what this means is, if you're not familiar with an if statement, then we'll talk about this a little bit further. But we're saying, okay, check this. If this is true, then run the code that's indented underneath it. And elif says, okay, if that's false, then also check this next one. And so the next one we want to check is right. If the right is pressed, then we'll set our velocity.x equal to 100. Okay, and because we're setting our velocity to 0 every time before we check, it's going to be 0 unless one of these is being held down. I'm going to interject a quick note here. I've already kind of shown an example of this by omission. The syntax, naming, spacing, and everything of coding is very important. If you recall earlier, I had the class just set to class like this instead of class_name, and you can see that I get an error. If you ever see a red highlight like this, just check down here and you can see what it's expecting. This particular error is confusing because it's saying we expect a colon after a class declaration, but really I didn't want to declare a class. I wanted to give this a class name. Okay, but that's your clue that something was wrong. Likewise, if you're typing and following along with my code and something isn't quite lining up, then just pause the video, take a look, and make sure that everything matches exactly. Capitalization, spacing, etc. You know, it's been mentioned, but the tab spacing is very important. gdscript is a tab-based language, so if I remove the indentation from that, it just completely ruins the whole set of code. Or likewise, if I had all of this indented in, it's going to give me an error as well, because it's saying that we expected something, but we found an indent instead, okay? So just make sure you double check all that. Again, like velocity, if I type it with a capital V, it might look like it could work, but then it doesn't, right? Okay, so all of this stuff is very important, and you'll start to learn and understand kind of the color coding. We've got these blue things, which are methods or functions that we're calling on the class. The green is referring to a class itself. These yellow strings in text are strings or text. We've got these properties or variables that are the light blue, and their assigned values are usually going to be, I mean, if it's a number, it's going to be this green color. But you can kind of see, make sure that your colors line up too, because if they don't, you might have typed something wrong. Okay, now back to the rest of the video. So let's go ahead and run this project. And now if I'm holding left, he moves to the left, and if I'm holding right, he moves to the right. So there we go. We've managed to build a really simple, playable character. And I know you're thinking this is lame, and some of you are more advanced, and this first video is almost useless for you. But for those of you who are new, I hope you are understanding some of the concepts that we're laying down, and that this is setting you up for the future. All right, now before we wrap up though, I want to just come back to my playground and just take a look at this Sprite 2D, and I'm going to give you a homework assignment here. And I want you to just build out a simple level, okay? And I want you to play around with these sprites a little bit. So I'm going to duplicate this. You can right click to duplicate it, or you can press Control D. Okay, and then once you've done that, you know, you can adjust these and just make sure you're trying out these different tools over here. You've got scale, rotate, and move, okay? And make a little world so that you have a place for your player to just kind of test out. And I'm putting walls on the left and right because I don't want him to be able to walk off the edge, right? If I test this out, I'll be able to stop because this wall is here. But if I go to the right, he'll just go off the screen and disappear, and I'll never get the player back. It's gone forever, off into the void, okay? So take the time, flesh out your level a little bit, and when we get to the next video, I'll show you what I've done with mine and talk about that. And if you're new to my channel and are enjoying the content, then please subscribe so you can see what's coming next. In the next video, we're going to start working on the player state machine, and it's going to be a way for us to make the code a lot more complicated at first, it'll seem like, but over the long run, it's going to simplify how we implement features and abilities on our player and keep them separated from each other. In fact, the full name is typically called a finite state machine because you can only be doing one thing at a time, and that's going to help us prevent code from getting too complicated. Thank you again for following along, and as always, we'll see you next time.